This is a flea under an electron microscope. And you guys have all seen pictures of fleas and plants and other things. And here's another picture. You can see how big the dog's hair is, or whatever animal this flea is on, and how big the flea looks. What I'm saying is the static charge, which constitutes gravity. If you looked at my theory, you'll understand that. But I want to show with this video, it's an analogy of why we can't use an electron microscope to look at one or maybe two atoms. We can look at thousands of atoms like this snowflake, but we can't look at just one, and I'm going to show you why. Okay, as you saw in the first part of this, an electron microscope lets you zoom in on things and magnify them extremely large, What I want to show using this demonstration, it's an analogy demonstration, is why we can't look at a single atom or two or three atoms with an electron microscope. We probably can't look at it with anything, a single atom or maybe just a few. So bear with me. What I'm going to show you is, I'll explain first, trying to look at the static charge that I say holds atoms together. That's the reason we can't look at a single atom. We're trying to look at the same thing we're made of. We're using detectors that are using the static charge to exist to look at the same thing another atom is existing on, that same source of energy. It's almost impossible. We may be able to do it someday. I wouldn't know how. So what I'm going to try and explain is it's like trying to make a metal detector that detects metal detectors. And actually it would be more like making a metal detector that detected metal detectors. You're trying to look for yourself. So as soon as you build this thing and turn it on, it's going to go off because it's going to detect itself. So it's practically impossible to do that because it's just going to find itself. It's useless to do anything else. It will see nothing else except itself. So it's like looking in a mirror or looking at nothing. So this is an analogy to show why we can't detect static charge, especially in single atoms. Because an electron microscope basically bombards things with high pulses of light. If you understand my theory especially, an electron is just a little pulse of energy, and you're bouncing it off atoms, and that bounces back, and that's what you see is the reflection. That's what you're seeing on anything. That's what we see, visually see, is the reflections of light bouncing off of something, and tells you what that image is. Color, shape, and its three-dimensional values. So what I'm trying to say here is when you try and direct that beam at one atom, that atom's going to absorb that, and it's going to use it. It's going to substitute it for normal gravity, static charge, and it's going to use that higher energy to exist on, and you won't see it anymore because it's using what you're trying to bounce off of it as its life force, as its energy. So it's going to absorb it. So there's no reflection, no bounce off. But when you have things with millions of atoms, like a flea or something, an ant, it's got millions of atoms taking in gravity. So that one shot of the electron microscope is not going to be absorbed because it's already got so much gravity going on. That's not enough to supply that whole mass of atoms. So some of it's going to bounce back, and that's why you can see things like an ant or a flea with an electron microscope. The reason you can't see one atom is because it absorbs it. So I'm going to try and use this to show you why it absorbs it and how it works in my theory. So this is a 12-volt battery. This is going to be our static charge in the universe. Supplies the electron function to all mass. And I'll use my voltmeter and show you that the battery now, our static charge is at 12.7980 volts. Our static charge battery is at 12.80 volts. So what I'm going to do is introduce one atom of hydrogen. Just one atom. Now our atom's here, and it wouldn't start running until it came together and formed a proton. So it came together, formed a proton, and I'm going to give it the electron function right now. So now it's got the electron function. Our atom is working. It's pulled together. It's holding itself together. Like my theory says, the electron is just the static pulses hitting it in sequential locations around the nucleus, giving it that electromagnetic or electrostatic bond. Tick, 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 tick. So it's got that now. It's got its bond. It is an atom. So we got a detection device here. Let's say it's an electron microscope. But right now, it doesn't exist because this is only existing from our static charge I've hooked with the battery. Well, this is not getting any juice from the battery. And I can detect the static charge going to it. If you see, with the meter, but the meter doesn't exist. I have to give it static charge for it to exist. Remember, this is an analogy to show you why we can't look at what's running that, the electric current or the static charge. So I have to jump in on my leads to my meter here and give it gravity, give it static charge. The atoms of this need to be held together with our static charge. So now, our meter is showing it's getting gravity just like our atom. And the battery in here doesn't hold the plastic together. It doesn't hold the metal parts together. It just tells the internal parts to make numbers. So the internal battery has nothing to do with this demonstration as far as what I'm trying to analogize here. So now our meter has gravity, our atom has gravity. So this is our electron microscope, and we're going to try and look at our atom to see what's feeding it, to see if it's there. So here we go. We touch in, and there's no change. Our meter shows the exact same thing it did. It's showing the same change. It just sees nothing. So when we hook an electron microscope up and we put one atom or maybe two atoms in there and bombard them, what happens is it basically stops everything. Everything just stops because everything you're bombarding that atom with, it's now using that energy to spin. It's substituting gravity with the electrons you're bombarding it with, so there's nothing bouncing back. Now, if you had a million atoms, they would bounce back because there's so many needing gravity that the electron microscope can't supply all of them. The one or two that it does supply is not enough, so you're still going to get reflections off of that electron gun because all the other gravity from natural static charge is still coming into them other atoms. It's overwhelmed that item, that atom, or that mass to where the electron will bounce off. The electron gun or electron microscope beams will bounce off. But when you're looking at one atom, it just stops because it absorbs it. So we have to turn around and give it gravity again. But we have to give our meter, our electron gun, gravity too. Like I said, it won't show up. We won't see anything. We will not see anything. So like I said, it's kind of like making a metal detector that detects metal detector detectors. It's deep and it's funky, but that's how I'm saying it works. The static charge feeds every atom in the universe. When you try and take a whole bunch of them to look at one, especially visually so you can see it, it's going to absorb what you bounce off of it. I mean, if you hit it with enough light or enough power, of course you'll overwhelm it, but how are you going to see one atom in a barrage of electric current or what have you? That's why it just absorbs what little bit we need to hit it with to try and see it, but it doesn't bounce off. It gets absorbed as a substitution for natural static charge or gravity. Thanks.